Hey, hi, Rajan this side. Welcome to my YouTube channel. So today we will be discussing the problem asked in LeetCode Biweekly Contest 144. So let's start with the first problem. The problem name is Stone Removal Game. So what it says, so there are two players, Elise and Bob, and they will be removing some number of stones from a given pile. And Elise is going to start first by removing exactly 10 number of stones. And so both Elise and Bob will be playing the game alternatively, and Elise will start the game by removing exactly 10 number of stones, then Bob by removing 9, then again Elise by removing 8, then 7, then 6, 5, 4, 3, 2, 1, this way, right? And at the end you have to return which player will lose the game. Losing means like the player who won't be able to make a move will lose the game. So you have to return true if Ellis wins, uh, or false if Bob wins, right? So it's a straightforward problem. Let's see how we can approach it. So you are given a pile of size n. So Elise is going to start the game by removing 10, right? So let's say this is your Elise, this is Bob. Elise will start the game by removing 10 from given n, then Bob by 9, then 8, then 7. So it will be this way: 10 to 9, 9 to 8, 8 to 7, 7 to 6, 6 to 5, 5 to 4, 4 to 2, 2, 1, right? So let's see how many maximum number of stones they can remove, like both the player. That will be 1 plus 2 plus 3 up to 10, and which is 10, 10 plus 1 divided by 2, which is 55. And if you look at the problem statement, it says that the max value of n is 50. It means that there is guaranteed that you would get a winner by playing this game, because the max number of removal is 55 and the max value of n is 50, right? This is the code of first problem. So this variable store who is your current player. So 0 for Alice and 1 for Bob, and this stores how many number of stones you are going to remove in the current move. So we know that we are going to start the game by 10, right? By removing 10 number of stones, and we also know that the max number of removal by playing the game by both the players could be 55, and the max value of n is 50. It means that you will surely get the winner at the end of playing this stone removal game, right? And since we know that you will surely get the winner, I'm just going through an infinite loop. I'm just checking if my current size of pile is more than the number of stone that will be removed in the current move. So if that is the case, it means that the current player can make a move. If you can make a move, then just remove that number of stone from the pile. And 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 from the problem statement we know that, so if your current number of stone that you are going to remove is 10, then in the next move it will be 9, then 8, then 7, then 6, this way, right? So I just decremented by 1 the number of stone that will be removed in the next move, and then I XOR equals to 1, so it will change 0 to 1 and 1 to 0. So if your current player is Alice, then the next player would be Bob, and if your current player is Bob, then the next player would be Alice. And then if this is your else condition, your else condition will hit, it means that your current player cannot make a move, means your size of pile is less than the number of stones which you have to remove. If that is the case, then the current player cannot make a move. So just check who is your current player. If your current player is Alice, so 0 indicates Alice. If your current player is Alice, it means that the winner is Bob. So, and we know that if the winner is Bob, just return false. And if your current player is Bob, then the winner is going to be Alice. So just return true. And we also know that you would surely get your answer. So you will never hit this below code, because we know that your winner will guaranteed be inside this loop. So just assert false and return -1. So this is the code of first problem. Now let's look at the second problem asked. This is the second problem asked in the contest. Let's see what it says. So it says you are given two string s and t having same length and two integer array, next cost and the previous cost. So what you can do in one operation, you can choose an index in the given string s, and you can change the character at index I in the given string s to its next character. And if it's a z character, then the next character would be a. So it's a circular fashion in a clockwise order. So so there are two operations. So like either you move the current character to its next character, or you can change the current character to its previous character. So if your current character is, let's say, B, you have, like, you can change it to A, the previous one. And if it's A, then the previous of A is Z. So it's a anti-clockwise. And at the end, what you have to do, um, you have to return the shift distance, which is the minimum total cost of operation that will be required to transform the string S to T, right? So let's see how we can approach this problem. So it says you are given two string S and T. So let's say this is your string S and this is your string T. Both are having the same length, so 0, 1, 2, 3, 4 and 5, right? You have to convert a string S to T. Let's say this is your index I. Like what it means, so converting a string S to T means that all index I belongs to 0 to n minus 1, your S of I must be equals to T of I. So you have to convert each character at all the indexes to its corresponding character at index I in a given string T, right? So let's say this is your current character S of I. You have to convert this to T of I, right? So there are two ways. Either you convert this to this in a clockwise fashion, or you convert S of I to T of I in an anti-clockwise fashion. What it means, let's say there are two characters B and C, B and D, right? So there are two ways. If you converting B to D in a clockwise fashion, so you have to do convert B to C, then C to D. This is one way, which is going next, then next to next. So this is a clockwise fashion. If you are going the second approach, B to D but in an anti-clockwise fashion, then what you have to do, you have to convert B to its previous A, then then the previous of A is Z, then Z, like the previous of Z is Y, then X, then so on up, like until you reach character D. So this is your one way and this is another way, right? So you just have to take the minimum, like so whichever cost is minimum to convert B to D, either going next to next, or previous then previous of previous. So it's a clockwise fashion and it's an anti-clockwise fashion. Why I am saying clockwise and anti-clockwise? Why? So A to B, B to C, then it's a Z, Z to A. This is a clockwise fashion, and the anti-clockwise fashion is going from A to Z, Z to Y, Y to X, and so on, then B, then B to A. This is your anti-clockwise fashion. So now let's see how we can implement this to a code. This is the code of second problem. So let's see what we are doing here. So this is the length of the given string. This is your answer, which will store the minimum cost to change S to T. And so what we are doing, we are going for all the characters, and then we are trying to change the character at index I in S to character at index I in T. So there are two ways to change C1 to C2. So the first way is going next, but then next to next, and so on until you reach C2. And the second way is to move to previous and previous to previous until you reach C2, and just take the minimum cost if you are going clockwise or anti-clockwise, right? So let's see how we can implement this clockwise implementation. So this is your C1, this is your C2. You have to change C1 to C2 and in a clockwise fashion. And so in a clockwise, what we do, we go to the next character. So this is the current C1, then the next is C1 plus 1, then the next would be C1 plus 2, then C1 plus 3, and like until you reach C2. So what we are doing here, so I'm taking the index of that character. So A will correspond to 0, B will correspond to 1, and Z will correspond to 25, right? So what I'm doing, so until your C1 is not equals to C2, what you are doing, you are changing the current character to its next character, and the cost of that operation is stored in next cost. So So this variable will store you the cost, the total cost to change C1 to C2. So it's a loop. We are going until you reach character C2 and just get the cost and increment the index. And we know that it's a clockwise fashion. It means that if your last character is 25, it means that if your last character is Z, then the next character is A, right? So in terms of integer, so the last character Z would be represented by 25. So the next character, so if you increment is 26, but 26 is not valid, right? So the next character is 0. So just change your current character to 0. So this will represent A and add the return cost. And your previous operation does exactly same thing, just a difference. So here, like in place of going to the next character, we are going to the previous character. So we are decrementing here the character. So C1, then it would be C1, then C1 minus 1, then C1 minus 2, then C1 minus 3 until you reach C2. So, and we know that if your current character is A, then the previous character is Z. So it's a anti-clockwise fashion, right? So if your current character is A, then the previous character is Z. So here, so your current character is A is means 0. So 0 minus 1 is minus 1. So but minus 1 would represent the last character. So you have to change index IDX 1 to 25. So 25 will represent Z and add the return cost. So the time complexity for this code is order of n into 26, right? And for number of characters, and 26 for doing one operation. So this is the code of second problem. Now let's look at the third problem. This is the third problem asked in the contest. So let's see what it says. So you are given an integer array nums of length n and a query array, and in each query you will be given left index and right index. So what you have to do for each queries, you can decrement any of the index in the given range L to R. You can choose any index in the given range and you can decrement it by at most 1. Means you can either decrement it or don't decrement it by 1, because at most 1 means either you can decrement it by 0 or 1, right? So 0 means don't decrement, 1 means decrement it by 1. And the second point says that for each index you can independently decide what you are planning to do, whether you are planning to decrement it or not. And at the end you have to convert the given array to a zero array. Zero array means that all the elements in the given array is like become 0. So what you have to do, actually you have to use the minimum number of queries to convert the array to a 0 array, right? So let's say out of 10 number of queries which you are given, you so the minimum number of queries which you can use to make the 0 array is 3. So you have to return the maximum number of queries that you won't be using to convert the array to 0, right? So if you know the minimum number of queries which you would be required to convert to a 0 array, then just return the number of queries minus minimum number of query that will be required. So our job is to find what is the minimum number of queries that we will be needing to convert the given array to a 0 array, right? If you know that minimum number, then just return q minus that minimum number, right? And if it is not possible to convert the given array to a 0 array, then just return minus 1. So now let's look at how we can approach this problem. So we know that you will be given q number of queries, and for each query you will be given left index and right index, and you have to convert the given array to a 0 array. So let's say you are at index I. So I belongs to 0 to n minus 1. So actually this problem is the third version of the previous problem. So so the problem name is 0 array transformation 3. So the first and the second was asked in the previous contest, LeetCode Biweekly and the LeetCode Weekly Contest, the previous last week contest. So so there also I use this information MPD. What is the max possible decrement at index I, right? So this MPD would tell you what is the max possible decrement which you can get at index I. So to approach this problem, we will first sort these given ranges in a sorted order based on their left index. So L1, L of I always be less than or equal to L of j for all I less than or equals to j, right? Then what we will do, for each index we will first get what are the ranges which can potentially decrease this given index. Means I will first find out what are the ranges. It means that so those ranges can decrement this index I whose left index is less than or equals to I, right? So I'll find all those ranges whose left index is less than or equal to I, and I'll keep those ranges in a priority queue. This is your priority queue. I'll use a priority queue here. I'll tell you why we required this priority queue. So, and after that, like after storing those ranges in a priority queue, I'll check if my MPD is already greater than or equals to num of I. So if my MPD is already more than num of I, so there is no need to do any operation because the max possible decrement is anyway more than your current number. So no need to do any operation. No need to do any operation, right? But if it is less than your nums of I, then you have to do an operation, right? So let's see how we will do this operation. So we know that this in this case you will required to do an operation. So let's see which range to pick to get the most optimal answer, right? So I'll pick whose right index is maximum, whose R is maximum, because we know that L is anyway L less than or equals to I. So just pick those ranges whose right index is maximum. Just take that range from the priority queue whose right index is maximum to get max number of decrement. Means let's say this is your index I, this is your L1 R1, right? This is your L2 R2, this is your L3 R3. So from here, like you can clearly see that if you take the maximum right index, you would get the maximum decrements, right? So this will potentially help you to reduce the number of operations. Just take the maximum. So this is the most optimal operation which you can do, right? If you look at, you would find that this is the most optimal operation to do. So just take the maximum R index, so maximum right index among all those ranges present in the priority queue, and take it and do that operation. And at the end, check if you can make the given array to a zero array or not, right? If you can make it, then so let's say this is your let's say this is your mn is the minimum number of operation to convert the given array to zero array, but you have to return the maximum non-doing ranges, so that will be q minus mn, right? And if it is not possible to convert the given array to a zero array, return -1. So now let's look at the code. So this is the code of third problem. So this is your size of the given array, this is your MPD. MPD is your max possible decrement, and mean required is the minimum required queries to convert the given array to a zero array. This is your size of query, which is q. I sorted the given queries based on their left index. So by default it sort based on their left index. So this is my index variable which will tell you the current query to look at, and this is my query end. So your query end of I will tell you the number of queries that end at index I, right? And this is a priority queue. So I'm going through each possible index from 0 to n minus 1. So I'm just checking. So here I'm pushing all those queries whose start index is less than or equals to I, as I discussed in my explanation part. So these are those ranges which can potentially decrement this index I, right? So, and for those queries whose start is more than I, they can never like decrement that index I, right? So I kept those so I kept the right index in the priority queue. right? Because at the end I would be taking the maximum, like, because as explained in the explanation part, I would need the range whose right index is maximum, and to get the maximum priority queue is the best option. So keep the right index in the priority queue and increment to index means like incrementing index mean going to the next query. So push all those potential ranges in the priority queue, then check if your MPD is less than nums of I, because if MPD is more than nums of I, then you can anyway decrement it, so no need to do any operation. If your MPD is less than nums of I, then you have to find some queries, right, from the priority queue to decrement at index I. So just check if it is not possible to convert the given array to a zero array. So so your MPD is less than nums of I, means that you have to do some operation, but you found that your priority queue is empty. So like there is no query to execute. Or if your top value is less than I, top value means that your right index is less than I, so there is no operation to do, like which you can use to decrement the current value at the index I. So return -1. Otherwise you will get a range which you can execute to decrement the current index. So, and it will always be better to execute the query whose end is maximum, right? So just execute the query whose end is maximum. End means your right index is maximum. So your MPD would be would increment it by 1, because you can decrement at most 1, right? In the problem it says that you can decrement it by at most 1. So let's decrement it by the max possible value, which is 1. So MPD would increment it by 1 minimum. So now you have to do one operation, right? Because if you don't do operation, you cannot like convert the given array to a zero array. So your minimum operation would be incremented, and this is your query end. I already told the number of queries that will be ending at index I, that will be incremented it by 1, and then just remove that query because you have already executed that query from the priority queue. So remove that. And we know that those query who already ended at index I, we cannot use these ranges for further decrement, right? So your max possible decrement would reduce by the number of queries that index I, right, whose right index is anyway I. So you cannot use these ranges for further decrement. So your MPD would be decremented by that query end I, and at the end return q minus mean required. So this mean required is the minimum number of query which would be required to decrement all the numbers such that your given array like become zero array. So q is your total size, q minus mean required. So this is the max number of queries which you won't be using at all to convert the given array to zero array. So this is the code of third problem. The fourth problem is a dynamic programming problem. I couldn't get it accepted during the contest, so I have prepared the video solution for the first three problem only. Yeah, if you find the video helpful, please like and subscribe to my channel, and please support guys. Thanks for watching.